We have a 16 inches, 2019. Um, this is 2019. This is 2021. This is M1 Pro. Um, it's been refreshed. Now the 2023 versions of this, they are M2 Pro. So mine has got the M1s. This was still running on Intel. The 2019 16 inches running on Intel. In my previous video, I did mention how you can easily identify 15 inches from 16 inches, and so this design was basically a design that Apple implemented in terms of the touch bar being separate from the Touch ID and the Escape key. So with the previous design up until 2019, um, so what Apple would do was to have the touch bar, the touch ID, and the escape key on one row. But uh, from 2020 they changed the design. However, in 2019, when they discontinued the 15 inches, the first 16 inches that they made, it came out with this design, and then afterwards it was obviously carried over. So this is a 2019 16 inches, still running on Intel, not the M1, and also that's why we see it's got a touch bar. The newer versions of them, the 16 inches, they've got no touch bars. This one says dead, which is low power. Uh, as you know, we do not connect charger to our device before we identify or we define the state of the device. So we will need a P5, which is a pendulum screwdriver, to take out the back screws. So before we do anything, as you guys know, first we need to know what state is the device in, because you don't want to basically create further damage on the device unknowingly. I mean, it's without knowing. So it is always better, when you have a dead device. I always stress that before you connect power to it, first of all, confirm what state the device is in. Otherwise, for example, you may have a situation where a buck converter is damaged and that buck converter is supposed to output say 2.5 volt, for example, to the NAND, and then you keep sending power to it, and I mean it just sends out PP bus voltage to your NAND, and then you get you just get a different scenario from the initial stage or the initial state of the device, just because you kept introducing power to the device. Okay, so this looks really good from the perspective of a technician. So technicians usually like a device that has not been attempted, because that way you'll be the first to actually diagnose the issue, identify what the issue is, and then basically solve it. Okay, so for this one, Peter was actually asking me. He said it could be the common issues of the 16 inches having a short on the NAND circuitry. We're really hoping that that's not the case, but yeah, because usually if that happened to be the case, there may also be a situation of one of the NAND being an issue, or one or two of the NANDs being an issue. So it's good that we're the first to open up the device. So first and first, let us disconnect. Let's disconnect the battery and do basic measurements to see if we have a short on the board. So first and first, we want to check if we have a short on our PB bus. Now this board number is an 820-00. 820-01-700. Yes, Peter, are you following? 820-01-700. Is that correct? You should follow the schema, the board numbers. It's very important. It helps you a lot. Okay, so this is the board view. Let's switch to the other side. The first thing we want to do is we want to see if we have a short on our PP bus line. If you check our previous videos, you guys will understand why we want to do that. So first and first, let's see what do we have on our PP bus. Black probe to ground, and then I also mentioned when you're measuring continuity, but it doesn't really matter which probe goes to where. But yeah, so black probe to ground, and then red probe. Let's see, what do we have? Okay, good. We don't have a short on our PP bus. Now, do we have a short on our 2.5 volt line, which is the SSD side? So let's check this side first, because we have the right and the left. So let's see, that's good. We don't have a short there, and then this side. Okay, so we have a short on this side of it. So we have a short on the 2.5 volt of this side, but we don't have a short of 2.5 volt on this side. Now, so And then you guys also see why I don't want to introduce power to the machine. So now we want to take out the board. So with that type of short, there are two things that we are basically praying and hoping for. We are hoping that the short is not on the NAND because it, number one is it makes the repair easy, quick. Number two, it saves the client his data. I mean, the client do not have to lose their data. However, if it's the NAND, it's gonna be a repair that takes time. Clients lose their data because the NAND has to be replaced, and then obviously after it's been replaced, you have to then the device will naturally put into DFU mode, and then you have to restore. Uh, yeah, the client loses data, and then the nine chips are not readily available. You have to order. And by the way, just see, guys, do you guys see what I'm just doing now? So see, I'm taking out a screw, but close to the battery pack. So usually when you are in this section of the board, in this proximity, it's better to kind of guide it because if you get like if it slips and then it basically punches your battery, that's it. You getting the damaged battery. So it's always if you feel like it might be risky for you, especially in areas like that, it's always better to guide the screwdriver to avoid any type of issue. And please, Peter, whenever you see the 16 inches, the 2021, whenever you're taking the screw out close to the NAND chip, be very careful. Remember that mistake that my brother made. Please. Yeah, you saw how I like you can use a T4 inside of it. Okay. Because you don't want to damage a client's device through the NAND and then it becomes a problem. Okay, so we want to quickly take out the board and see which and to see where our short is located. We are really hoping and praying that the short is going to be on a cap and not on one of the NANDs. That will be really good because the repair will be quick and the client will also have their data. So, and then something else is it's always better to use your fingers. And if you want to use, in terms of disconnecting the cables, if you need to use a tweezer, make sure you have full control over your tweezer. You don't want to, you don't want to damage or break anything by using a tweezer because you don't have complete control over it. 5 minutes more. Especially in tight places, it's actually better to use your fingers so that you do not, unknowingly. And as a general rule, try as much as you can to use your finger wherever you can instead of having to use a, you know. And then when you're removing the board, always, do not force it out. As you're taking it, and just be aware of what cable has not been disconnected, which will just prevent your board from coming out. So you don't want to force it out. You gently take the board out and just be aware of what cable has not been disconnected. Okay, that's out. This still needs to be dusted. Let's put the shell aside. Let's look at our board. First and first, we can dust the board from this side. and then on the other side. Oh yeah, so by the way, before we move to the other side, you guys saw the sequence that I took. So the first thing we do is we check for a short on our PP bus line first. Now, if we don't have a short there, the next thing we want to do is we check for a short on our 2.5 volt line. So that we can check on this cards here. I'm just gonna quit that and start that again. Okay, so this is what you can easily do even before having to take the board out. So so you check for a short here, PP bus, there is no short, good, and then you come here, check for on your 2.5 volt line here, which is 2.5 volt to your 9, you see that we have a short. And then the other side, I also did check for a short on the other side, which is, you see that is also a 2.5 volt line, and then I see that we don't have a short, and then I obviously now have to come to this side. So there are two sections in terms of the SSDs. You have some populated on this side and others populated on the other side. So when you check for PB bus no short. You check to see if you have a short on the 2.5 volt line. If you don't have a short on that side, you check on the other side if you don't have a short. Now, generally, if we didn't find any short, the next step we were going to take is connect the charger and see what you have on our PB bus voltage. If we have 12.6, obviously that tells us that we have 20 volt on our PPDC, but if we have 12.3, that tells us that we have about 5 volt on our PPDC, which is to say that our PP bus is not being completed. Now, generally, what I would do is after I confirm that we don't have a short and we don't have an issue of one of our CD3217 being faulty, the next thing is to put the machine, to basically place the machine in DFU mode and then try to revive it first, because that saves client's data. And if revive fails, usually if revive fails, usually I don't go to restore, because usually in a situation like that, should your revive fail, restore does not fix the issue. So here we're on the other side, and we're having a short on this side of the board. So let's flip the board to the other side and see what we have in this section. Let's take a closer look. Okay, so here I see a cap that I am praying and hoping that that is our problem, which is this guy here. I'm not sure if you guys can see that. This one here.
Yeah.
Yeah,
Yes.
can you guys can actually see. So it's peeling off already. So with that cap there, so let's just measure. Just you guys see. Let's see. So that's it. So what we want to do now is we want to just remove the cap from the circuitry like that. Tweezer, we use a tweezer to remove it. We don't have to necessarily use. Okay, and the next thing I'm gonna do is I'm gonna check again and see if we still have a short. Alhamdulillah, we don't have a short. That's very good. Usually,
C72. Okay.
okay, so the cap, um, that cap, it's C9586. So usually when I want to measure at that section of the board after the cap is out, my heart goes really, because you just don't want. So now, and now we can dust it out. So that is the cap that basically failed, and alhamdulillah, the NAND, it's still fine. We do not have to worry about that. Peter, what do you say? Do we need to replace that?
Yeah.
Should we replace it?
Yeah. If you want.
Yeah, because I mean, you would argue, but it's if you're replacing it, because how that failed is basically because of moisture. So because of that, the board gets warm, and then a bit of oxidation starts to form, and then the cap then obviously fail in that manner. So we can choose to replace it, but obviously when we replace it, it's that's still gonna happen over time. So, but yeah, uh, let's test our board first. I'm gonna go through it now, and then when we come back, then we can test and continue from there, because it's already 3:32 now. Okay. See you guys when I come back. Okay, so what we just need to do is we just put back that component since it's saying we should. Okay, let's put back the cap. And by the way, if you don't put it back, uh, that's fine. Okay, it's prepared. Let's take one from here. Mm, okay. Okay. Uh, yeah, we won't. We won't just put it together. We check to see where we should. We learned from the other time we had a repair like this one. Maybe we just assume all is good, and then we wait. It's that's a complete short. Like that's a complete, not like a partial. No. Okay. It's good we didn't apply power to the board yet, so it's still good. Let's take out our cap.
Bridge.
Yeah. So it's making its way. Just, just a little bit so we can quicken the process. Hmm? It's taking forever. Let's get another inductor real quick. Okay, use this one here. Imagine if you ran power through the board without testing. Then a fixable board
So
into,
that C9586,
yeah.
if it is not present on the board, the power goes direct to the chips.
No. So C9586. It's one of the many caps on it. So you have C9586, you have C9588, you have C9584, you have C9552, uh, and then you have C9592. So basically, the work of so two things that's going to do. So number one, it will basically smooth out the voltage that goes to the chip, and then number two is it will act as a battery.
Okay.
You understand? So it's
2.5.
2.5 volt, yeah. So okay, we don't have a short. That's ground. And then have a short. Okay, so next thing is we want to clean that section of the board, test our board, and we should have a working board. When you're working around your NAND chip, you just be very careful. You don't want to damage your NAND chip. Be very careful, especially client's data. You don't want to lose the client's data. Need to order some of the NAND chips as well. At least 512s instead of 512s. And maybe 1 terabyte also. Okay. Our board looks clean. Just give it a bit of a dusting. Then we can test. Do you have to collect the other machine?
Okay, but that is present.
Okay. Now let's see if we have a working machine. We hope we do have a working machine. So, but sometimes you find people this allowing it to go.
And
Yeah, shouldn't be
the
under.
board doesn't say it here.
The board seats, but you, yeah. And then when you are putting your machine, so we're not putting it together now, but when you're putting your machine together, it's very good that you always, double check, be sure everything is connected. Don't be in a hurry to finish. Make sure the screws are going into their proper places. Uh, you don't want to make horrible mistakes, mistakes that just, imagine somebody who, they came to fix a device and then they go into a different country after the device is fixed. Yeah, and then it turns out that, for example, the touch ID, the power button is not connected. And then the person, and because of the design of the machine is going to start. You won't notice it right away. And then the person,
When you're not close to the charger.
say again?
When you're not close to the charger, then parent
Yeah, but there's no way if you remember, in order to process a cold boot after disconnecting the battery, you need a charger. So the client goes and see that clip also breaks out easy.
always wanted to see you putting that there.
It's actually very easy, eh?
I saw it.
Like it's very easy. You just need to identify which is the front, which is the back.
Okay.
Yeah, you see, the front you have two small, what is it called? Kind of like the two small clips at the front, really small. You see here, it's smooth, but the back is not going to be that smooth. At the back, okay, I'm just going to show you another one. So this is the front, yeah? It's smooth, nothing. Now, the back, can you see that? One, two,
Yeah.
yeah. Because that helps hold to kind of put pressure on.
Place it.
Yeah. So that's
So if
just
you
the
take it
difference.
out, those goes and
Just flip it. Yeah, that's it. It's very very easy. But if you don't get it, you might be struggling. You see, it looks very small, but that's just the details.
small
Just
details.
the same thing with keycaps. Keycaps,
Yeah, yeah.
the way you place them, front and then back,
Yeah.
just like this, and then clip. So if you don't know, you'll be struggling. Small details.
Mhm.
So on the 2019, which is when basically when Apple kind of introduced the physical angle sensor cable, the 2019, the 16 inches. When this angle sensor cable breaks, when it's damaged, you still can put in another angle sensor and then you're good to go. You have a working angle sensor. But with the 2021, your angle sensor is paired, so which means if you have a faulty or damaged angle sensor, unfortunately, this replacement is not going to work. It's almost treated like a touch ID. Okay, let's try to put one or two screws just to hold it in place so we can do our testing.
But that is why I noticed on that angle sensor there is like a small IC on there.
Okay, so you're thinking
So if you
you
if you take
transfer.
out that IC and transfer it to another cable, is it going to?
I didn't try that yet. That makes sense. I didn't try that yet. I've actually not I've not really looked into it in details in terms of it makes sense because the cable is just a means.
It's just a cable
Yeah,
to transfer
so
power. Yeah.
Yeah, I didn't look into it, but that makes sense. Okay, so let's see. Do we have a working board? Let's connect our charger. Uh, okay, we did confirm that we don't have a short, but let's just try again. Okay, no short, PP bus. No, okay, yeah. Actually, I shouldn't actually be even measuring PP bus short when I have my battery connected, but yeah, that's fine. Okay, because usually when you disconnect charger and then the battery the first and then the first time when you putting the machine back on, you need a charger. Okay, that's a good sign. That's a good sign. That's good. Do we have Apple logo? Not yet. That's an Apple logo. That's a beautiful Apple logo. Okay, let's just do a pair and reset to get that beautiful Apple sound. Okay, so a pair and reset is Alt Command Add and P basically. Ah, that beautiful Apple sound. Let's try that again. Okay, just restart the device one last time. Let's see. Start the device again. And by the way, say our battery is flat. Battery is completely zero. So leave it on charge. And, yeah. Okay, guys. That's it. And usually, depending on, as you guys see that the touch bar is not on. So once the client imputes their password, the touch bar will be activated. And then another thing also to notice in the type of operating system that the machine has, see here it says 0%, it doesn't show an icon, the charging icon. So note that the reason why that is because you do not have, the password is not imputed. So once you impute the password, you will also see that, yeah, the device is charging. And also that is dependent on the operating system that you have installed. Okay, thank you guys. I will see you guys in the next one. This is a completed repair. It's going to go through, give it a bit of time to charge, shut it down to go through the standard testing process after we have assembled the device. And then, yeah, this is a completed repair. So, what's the job number of the machine?